Hello, everyone. Just want to follow up on the discussion questions for week 3, module 3. Um, as most of you identified, reliability, validity, and sample error are three concepts that are used in quantitative research. They could expand beyond that, but let's just talk about their use in quantitative research. First one is validity, and validity is the assurance or the assumption that the tool that you're using is measuring what you actually need it to measure. And that might seem kind of intuitive. Why would we pick a tool that doesn't measure what we think it's going to measure? Well, it's really easy to get off track when you're dealing with a tool that might be measuring something like reading comprehension or some other performance metric. But yet it's doing it in such a way that it's not quite answering the problem statement or research questions, or it's not addressing the hypotheses in exactly the way that you needed to address the hypotheses, so you can reject the null and accept the alternative. So it's important to make sure that whatever tool you use, or even whatever population or sample you use, is going to yield a valid measure of what it is you need to find. The second concept was reliability. And reliability, most of you figured out reliability was the ability for a tool to yield a similar result when used in a similar way. And that's important because if the tool is weak, or there's something wrong with the tool, or if the survey instrument is biased in such a way that the bias resonates with one sample and not with another, or one part of a sample and not with another, then it's likely to yield wildly different results even when it's used with a similar sample. So that's something that's got to be built into a tool such as a survey, that you're able to use it in such a way that it will yield a similar result if it's used in a similar way. And sample error is the error that is introduced when we start using the sample instead of the population. And as we do with inferential statistics so often, we have to use a sample because we do not have access to the entire population, or it's just simply impractical for us to do that with the entire population. So sampling error is what gets introduced. And in module 4, you're going to do a little bit of work with what we call biased and unbiased standard deviation. And the unbiased standard deviation is a standard deviation that is calculated on the whole sample. And the reason why it's unbiased is because we don't have to worry about there being a sample. We know that we can calculate the, population. We know that there's no need for using a sample. And so when we calculate the unbiased standard deviation, we're looking at the entire population. It's spot on, dead on accurate as far as the standard deviation goes for the population. When we use a sample, we are now using a biased standard deviation. And the biased standard deviation is biased in the sense that one of two things. One, there's sample error involved because we have to basically calculate a standard deviation and presume that our sample is representative of the population such that what we find with the sample applies to the population. The other thing that is causing it to be biased is that when we calculate the standard deviation, we are more standard deviation for the sample, we are more conservative in our estimation, meaning that the standard deviation for the sample will always be higher than the standard deviation for the population. That's because we divide by a different factor. We divide by n minus 1, and that thereby lowers the amount of standard deviation that we actually have to spread across all of the different sample. We do that because we want to be more accurate. We want to be more accurate when dealing with a sample. So that's the difference between biased and unbiased standard deviation. I think I already covered that in the video. This next week, I'm just going to have you work through a couple of more numerical calculations. These are just basically getting more comfortable calculating things like mean and range and standard deviations in Microsoft Excel. And this is sort of a precursor to where we're going to start to take off now and look at some of the more advanced tools in Microsoft Excel in the data analysis package. Thus, if you have not installed the data analysis package, go ahead and do that. It's a pretty easy process. You go into Microsoft Excel, you go over to File, you pull down to Options, and then I think it's Add-ins after that, and you can see which ones have been installed. It comes with them. They might as well install them, but they don't. And so you have to check on it and indicate that you would like to install the data analysis add-in. Some of you may already have it. If you don't, try installing it. If you have any questions or problems, let me know. And I guess that's all I have for our wrap up for this module. You guys are great at communicating, so I appreciate that. Your discussion boards are awesome, so I appreciate the work that you put into those. And I will continue to follow you through all the discussions as we go. All right, have a good rest of your week.